Today is Saturday, January 22. Welcome to the data visualization workshop. Um, we are going to have a two-day workshop, all Saturday today and all Saturday, all hours of Saturday next week. In between these workshops, in between these two full-day sessions, you can reach out to us, and I hope you do reach out to us uh, to clarify your doubts, to review some of the stuff we did in case you felt we went too fast and so forth. By we, I mean a faculty here of 4 people. I would be your instructor, the primary instructor. I am Asif. Then we have in the in the California time zone, we have Kate Amon. She's here in this Zoom meeting. And we have Harini Datla. She too will be joining in a few moments. And in the India time zone, we have Kyle Busy. So around the clock, essentially, if you get doubts, one of us would be there. I would encourage you to join the Slack group. If you haven't accepted the invite, please do accept the invite. If you haven't been visited the course portal, and this is the course portal, then it would be a good time to visit the course portal right now and make sure that you can access it. As this course develops, we will be adding a lot of material to the course portal. Right? All the notebooks from today, you will find that they get added. There'll be reading materials, and I'll put references and so on and so forth to the course portal. Now, there is, in this particular workshop, there is actually a project which is optional, a capstone project. The capstone project is you take any data that you like, that you find fascinating. It may be one of the classic data sets, or it could be a new data set in your workplace. But if it is your workplace data set, please do make sure that you have approval or a release from your employer to use that data set for your capstone project. Right? Obviously, you don't have to give us the data set or do anyone share it with anyone, but to use it in your capstone project, and of course, keep it within your company, but you'll have to present it here. On the last day, on the next Saturday, in the last hour, for those of you who do the capstone project, there will be a presentation in the lobby, which is at the back, and most of you are familiar with the lobby. And for those of you who are remote, we'll do it remotely. And it will still be in the lobby room. What it would mean is you'll be presenting your work to this participant group, to this batch. And it's usually a lot of fun. You get a lot of feedback and encouragement from your batchmates, from other participants in this batch. So start thinking about what data set you would like to do a presentation on. Right? And that is something to do. Now, there is no study required outside this particular 2 Saturdays. It isn't that we'll end the day with a lot of homeworks. Whatever you learn here, that's about it. And that should be sufficient. However, should it interest you to pursue it more aggressively, reach out to me and I will give you a lot of references. Data visualization is a very important topic and a lot of people take a lot of pride in it. So it is worth mastering it very well. So that's to the logistics of this course. We will start. I apologize, I gave mixed information. At one point, I said we'll start at 9:30. And what I meant was, I suppose, 9:30 Asian Standard Time, which means I plan to start strictly at 10, and now it is 10, and we have started. But next day also, next Saturday also, will start at 10. I've given the end time as 6. But that part is 6 plus minus 2. It all depends upon what space we move in this workshop. There is a certain amount of material. The curriculum is there. There is a quantity of learning that we must do to become very fluent with data visualization. How much time it takes depends on the pace at which we can collectively move forward. Now, the way this course will work is, I will move forward at a minimum pace. But if you fall behind that minimum pace, then please in real time reach out to Kate and to Kyle privately and they will keep, and Harini, and they will help you catch up. Lunchtime is a great time to catch up. But because the nature of this workshop is interactive, we will do things right now. There will be very little talking except in the beginning, what I'm doing now, and maybe another half an hour of it. After that, no more theory, it is all practice. And so we need to move at pace in this particular workshop. Right? So that's to the logistics of this class. Now, coming to data visualization. Many of you have been students of machine learning here, some of you of machine learning here, some of you in university systems and so forth. When we do data science, machine learning, statistics, and the various variants of it and artificial intelligence, this is the broad subject that looks for meaning in data. When you search for meaning, patterns, underlying explanations in data, we use many things. We, for example, use algorithms. We use things like logistic regression, linear regression, random forest, and all sorts of machine learning algorithms to model the data and make it do predictions. And when it makes accurate prediction, we feel that our model has somehow learned to explain the data or understand the data. Right? It has figured it out, which is all good. Those are inferential models. And when we do clustering, when we do dimensionality reduction and things like that, we search for patterns in data. We look for clusters and things like that. And all of that is good. But perhaps the most powerful method that helps us, or approach that helps us find meaning in data, I would argue, is data visualization itself. Of all the machine learning algorithms or machine learning engines that you can imagine, the engine that has been trained for the longest time is the human eye and the cognitive intelligence behind the human eye. Today, for example, you see Google running its car all around the streets and gathering data, and you hear that it has crossed so many million miles of road travel, 100 million miles of road travel, and the cars and the sensors in the car have been gathering optical data of the roads, and the car has been learning from that. This has been going on for what, about let's say 5 to 10 years. On the other hand, the eye, if you look at the evolution process, we know that eye developed. We know that fishes have eyes. We know that even more primitive organisms, for example, amoeba and things like that, they respond to touch, they respond to sensations. And you see you see the early beginnings of vision of some form. But certainly eyes, the fishes have it, the reptiles have it, the mammals have it. Right? All the amphibians have it. So eye has gone through at least 100 million years of learning. And just pause and think about it. We have a machine learning engine that is so absolutely lightning fast that you wake up and when you see your dog, it doesn't take you, you don't even realize that your eyes have recognized a dog. When you look at your child, when you look at your parents, you don't realize that there is any recognition part or inference part involved, but it must be happening because what you get is just light and color entering, wavelengths of light entering your brain at different intensities, entering your eyes. They are received by the rods and cones in your eyes, the biological units, the biological sensors. From there, the nerves pick it up and the interpretation, the inferential engine comes in and it immediately says, my dog, or my child, my mom, and so on and so forth. So we should never underestimate the power of visualization, the power of representing something visually, because meaning becomes much more accessible in the data. Now, data visualization there are many things you can say about it. Generally, there is a belief, especially in technical circles, that data visualization is eye candy. right? The real thing is to build machine learning models, or the real thing to do is to do some projections in Excel spreadsheets, or to do things like that. Or real thing is to work with database and do SQL queries and whatnot. And we are all amongst us people who deal with data in some form. In the minimum, we make to-do lists, right? And most of you have experience with databases. Most of you have experience with data manipulation, data pipelines, in some form or the other, as you do in your workplace. And many of you have taken machine learning courses here or elsewhere, and you always are enamored with algorithms and their ability to learn and create inferential models or pattern recognition. But today we'll focus on data visualization. So what is visualization? Why is it relevant? I have a quote from two of the great people in this field, two great psychologists and not psychologists, sorry, statisticians and data scientists. So John Tukey, one of the early statisticians, says the greatest value of a picture is when it forces us to notice what we never expected to see. That is it. Many times, when you look at data, you say, data can overwhelm you. We can understand 10 lines of data or 20 lines of data. If that, if the data has multiple columns, we already begin to get lost. So then we start using statistical measures, mean, median, mode, kurtosis, skew, all of these measures, min, max, range, to get some sense of the data. Each of them is a statistic, a range of a data, of a set of values of a random variable is a statistics. Min is a statistics, max is, mean is, median is, mode is, kurtosis, skewness, and so on and so forth. You can go to higher moments and you can create other statistical descriptions of the data. But at the end of it, they're summary descriptions of the data, right? And as you will learn, while they say a lot about the data, they are necessary but not sufficient, and we'll come to that. Visualization also has the purpose of storytelling. See, data, when it comes, there is a generative force behind it. That generative force you don't see in the data. Often when you visualize the data, it gives you a sense of where it came from. What is the dynamics behind the data? So we will do that. Remember, when we do visualization in this particular workshop, our goal is not to create a pretty, flashy plots and graphs. That we should leave to the marketing people. Here, visualization, when you talk about it as a formal subject, primarily, it must be illustrative. It must be explaining. It must tell a story. Its purpose is that, to tell the story, to explain, to illustrate. Aesthetics is a secondary concern. It doesn't mean that you create ugly plots. Ugliness is offending to the eye. We must make it aesthetics. It must have aesthetic. So when we do it today, we will learn about good visualization and bad visualization. We will learn about what are aesthetic rules and we'll proceed. But I'll start with a few basic principles. In visualization, less is more. So quite often you see bar charts. And have you noticed that the bar charts that you often see on the internet, if you were to Google it up, they will often have a three-dimensional shape, right? They will have color gradients associated with them. And they will have very fancy look to them. Generally, the thinking is that is not a good idea. Visualization are at foundation scientific plots. In scientific plot, explainability is important. And there is a principle which I call the principle of least ink, or as one of the great people in this field of data visualization, Edward Tufte, a professor at Stanford, says the data ink ratio. You should use the minimum ink to illustrate clearly the data and explain the data. So don't do things which are just cutesy. Do things that will elucidate the meaning of the data much more, right? Or the character of the data much more. So with that guiding principle, we will we will get started. See, when we talk of languages, the reason that we can, in English, for example, we can construct any sentence we want to express any thought we like. There is an infinitude of words or sentences that one can construct that are not nonsensical, that express some idea or the other. Yet, when we construct a sentence, the implicit assumption is the reader will understand what that sentence is. A sentence that is a random jumble of words is incoherent. It doesn't convey a meaning. So when does a sentence convey a meaning? Of course, there should be a thought behind it that the sentence expresses. But for it to be understood by the other person, there should be a common set of rules. And those set of rules are the grammar of a language. A grammatically incoherent sentence is jarring, if not completely incomprehensible. So there is a grammar, and the grammar helps you construct any kind of sentence that you wish. With the world of data visualization, what happened is people started out in a very ad hoc fashion. There are many, many libraries that are ad hoc. Any developer who thought he knew or she knew how to create a library that would be useful to others. Usually it starts with creating an API, a few functions or methods or classes that you find useful. And then after a little while, you feel like sharing it with the world, and you share, and it becomes a visualization library. So there's a plethora of libraries. Then in this space came a landmark work, which we'll adhere to. There was a seminal work and it was represented in a book, in a research paper and a book. The book is called The Grammar of Graphics. And it basically says that much as language has grammar, visualization can also be thought of with basic primitives and a grammar that defines the relationship between these primitives, right? So for example, data is a core component of visualization. But so is the aesthetic elements. Are you laying the data as a line plot, as a bar plot, as a scatter plot? What are you doing, right? For some data, imagine some two-dimensional data, right? So there are aesthetic elements, and then there is data. And it is, how do you put the two together? If you have a very structured set of rules, then it can help you create very, very powerful visualizations without a thought. You can look at a very complex visualization, and in your mind, you can break it down into pieces. And as you break it down into pieces, you will realize that, well, it wasn't that hard. It is a composition of parts, very much like a word, a sentence or a paragraph is a coherent composition of words. And we will learn that language. That is the purpose of this workshop. So it is not just to learn this library or that library, but it is to learn a structured way of creating any visualization that you want. Right? And the closest analogy that I can give you is those of you who are familiar with Photoshop. If you are familiar with Photoshop, you realize that what you do, you create a layer. When you create a very complex visualization, you don't just do it in one single thing, one complex bit. You create layers upon layers upon layers. And quite often, a good Photoshop work contains, and I used to do Photoshop. I haven't done it in almost 6-7 years now. But when I used to do that, sometimes a good representation, a visualization in Photoshop or a picture in Photoshop, by the time you're done, would have something like 30, 40 layers to it or 50 layers to it. I hope this experience resonates with those of you who have done Photoshop. And you know that each layer is contributing something to the overall picture. But of course, when you see the picture on a monitor, when you export it out as an image, those layers are not visible, except to the trained eye who can discern, the various layers that must have gone in constructing this picture. So in the same way, we'll develop an ability or a mental training that can help us see any visualization and in effect see the layers, in effect see the components and say, aha, I know how this was built. And sure enough, I can go ahead and build it. That is the purpose of this workshop. Now, in the world of Python, we will be using Python. The title of this workshop was Data Visualization with Python. It is primarily addressed to data people, people who do data analysis, whether in Excel or whatever it is they do, or data scientists, or variously machine learning engineers, AI engineers, and so on and so forth. In other words, and people who do SQL and so on and so forth. So in other words, the entire cabal of tribe, or collection of tribes or cabals that deal with data in any form whatsoever, and would like to visualize it. So it has a pretty broad appeal, but we will use Python as a primary language. It has emerged more or less as a de facto standard in the data community, or the data science and data engineering community. So we will be using that. Now, as we proceed, and this is all the theory that we will have, just to give those of you who came a bit on time, actually at 10, or a little later, we will have lunch from 1 to 2:30. It will be a working lunch. There will be 2 articles or 2 papers that I will encourage you to study. Both of those papers are here. Do you see that visual and statistical thinking? I would like you to read this paper and of Edward Tufte and his writings, and a paper called The Grammar of Graphics. We just talked about grammar of graphics a little while ago. So with that background, it may interest you to go read this. At the same time, Edward Tufte's thinking that visualization should be minimalistic is captured in this particular article. Now, Edward Tufte took minimalism too far in many ways. So the pendulum went from having a lot of what is called chart junk, fancy 3-dimensional bar charts with gradients and fancy fonts and gimmicks and so on, lots of gimmicks. The pendulum swung. The belief was that you must have absolute minimalism. And that was Edward Tufte's thinking in the visualization space. So that became a school of thought, minimalism. But the pendulum is actually swinging back. There is a whole body of psychological research, a visual perception research, that shows that chart junk is not quite evil. When you take a plot and you inject some amount of aesthetics to it, or some cutesy element, you make it more memorable. People tend to remember what the plot was saying much more. So the second paper, this is a paper, it sort of brings back, and it says, in minimalism, we have gone a bit too far. Let's bring in some amount of it, which doesn't mean that we clutter our visualization with chart junk. I would like you to read these 2 perspectives over the lunch. So you have a sense of how the visualization community thinks about visualization, and what are the opinions and schools of thought in this community. All right. We are going to do visualization using many libraries, but 4 of them primarily. We will use Matplotlib. Matplotlib in this space is the earliest library. It is based upon NumPy. It predates, interestingly, the grammar of graphics. So it doesn't strictly follow the grammar of graphics, but you can impose a grammar of graphic approach as you work with Matplotlib. And that is structured approach I will be explaining in the subsequent hours. Now, over Matplotlib, people felt that it's too low level, and to get an aesthetically pleasing graph, you have to do a lot of work. So then Seaborn library came about, which gives you, in many ways, ready to use components, ready to use plots, right? Says that you just plug in your data and it looks good out of the box. You don't have to do anything. What does it do? It is based on Matplotlib. Essentially, it means that the creators of Seaborn have done the hard work for you. Matplotlib you can think of as very powerful, but a low-level library. Then one interesting development came. Matplotlib is fundamentally based on NumPy, which is a library that helps you manipulate multidimensional arrays. Right? That's the simplest way of thinking about it. Now, within the data community, a very popular representation of data is called data frame. A data frame is essentially like those of you who are familiar with spreadsheet, think of it as a spreadsheet. It has rows of data and they're columns. The columns could be numerical, the columns could be categorical, for example, name of cities and so on and so forth, if you're looking at weather in different cities, right? So that representation goes way back. The R programming language has data frames as a fundamental unit built into the language. Then in Python, data frames don't come built into Python because Python is a general purpose language, not a statistical language originally. But the pandas library, which most of you are familiar with, but some of you may not be because it's your first encounter with data. Think of pandas as a Python's way of doing spreadsheets and manipulating a spreadsheet of data or a data frame. Right? Its core unit is the data frame, and there are operations that you can do on the data frame. So now one of the things that happened is there was a disconnect. You have matplotlib that thinks in terms of multidimensional arrays, and now the most popular representation that people are using is pandas. So there is a bridge between the two. Pandas can use matplotlib under the cover seamlessly. And in a way, it feels more intuitive. So for example, if you have a data frame which has columns X, Y, when you say that data frame dot plot X comma Y, it feels very intuitive, right? So that is, we will actually, wherever possible, take the approach of using pandas first. If we can do it using pandas, we will do that, right? Then there is another group of people who have, as I mentioned, there has been actually a landmark work when the grammar of graphics as a theoretical foundation came about in visualization world. Two very, very powerful libraries, at least two, came about. In the world of R, it was the ggplot. And ggplot is a literal representation, and Hadley Bickham is, of course, the creator of ggplot. So this article that you're reading is the seminal article in which he introduces his rationale behind ggplot. And the other library in the world of JavaScript is from Michael Bostock, some of you know, is the D3.js. D3 library, when it came about, it was a game changer. It pretty much cleaned the slate of a lot of other libraries that people had created. It's the big gorilla now. Now, D3 is a little hard to learn. And so what people did is, it's a very low-level language, D3. So people have created layers over that. For example, there is Vega and Vega Lite. There are other libraries that people have created in the JavaScript world that facilitates it, that makes it a little bit more rapid to create standard plots, very common plots. Whereas D3 is completely a representation of the grammar of graphics. You can, using in a systematic process, you can create just about any visualization that you like. But you have to go down to the graphic primitives. Now, in the Python world, there have been efforts to leverage the whole D3 movement. And using that, there are two particular libraries that we'll focus on, Altair and Plotly. Altair lives upon Vega and Vega Lite, which is sitting upon D3, and Plotly directly uses D3. Both of these libraries are very pleasing and they're interactive. Matplotlib, unless you explicitly state so, it produces static plots, static graphs. Whereas the Altair and Plotly, because of their D3 lineage, JavaScript lineage, they are highly interactive out of the box. So those are the libraries we'll focus on. I will just glancingly mention Bouquet. I initially thought we'll have time for it, then I realized we won't use it extensively, but I'll introduce you to it. Next, you see one more library in this list. It is called ManimGL. Now, some of you may be familiar with the videos called from the channel called 3 Blue, 1 Brown, explaining the mathematics. I don't know if you have ever seen those very beautiful visualizations that explain math. It was practically a revolution in teaching of mathematics. When you teach anything, Fourier series, gradient descent, this, that, right? Any basic thing, any mathematical concept, visit the 3 Blue, 1 Brown channel, and you will see this beautiful, evocative videos visualization videos, right? And I trust most of you are familiar with that. If you are not, acquaint yourself with that, you'll love it. The beauty of mathematics is visualization. Now, the creators of three blue, one brown, they literally created a 3D, a data visualization library based on OpenGL, right? Which is called MANIM, right? MANIM is mathematical animation. If time permits, which likely it won't, but so I may make it some extra sessions later on. But if you're interested, if we get time, we'll do a MANIM and we'll create one of those, reproduce one of those beautiful visualizations. Right? So this is the scope of it today. So, well, I would like to start with the importance of data visualization. Guys, look at this, a famous visualization. This, some of you may be familiar with. It is a Florence Nightingale and the Two Roses. It has a tremendous historic significance, and I'll start with that because it is the history of data visualization. One can arguably say that the field of data visualization started with this amazing person, amazing human being named Florence Nightingale. So a very quick bit of history, and this is, and I would like to end the theory with that, and we'll go straight into labs. Florence Nightingale was a historic figure, of course. Many of you know her history, but I'll recap. As a young girl, she had a unique passion. Whenever she would see things, she would, in a diary, note it down, how many. She would quantify it in numbers. And she used to carry a diary of numbers, of facts as numbers. Right? Quantitative, because she felt that objective facts are sort of precious. And then, as the story goes, she one day was sitting on a bench in one of, she came from a fairly very affluent family through one of the noble families, and she was sitting in one of her manors, the benches in the garden, and she felt that she heard a calling from God in some sense, let's put it in modern language. She had a moment of epiphany in which she felt that she has to dedicate her life to a purpose, but it wasn't very clear what purpose it was. And she went around the world. She decided not to marry and do all sorts of things. She went around the world searching for what that purpose was, right? And in the process, she did amazing things. She went, there was a war in Crimea. Is it Crimea or Crimea? Please excuse my pronunciation, a land which is close to, well, it is near Ukraine, or I think in Ukraine, the Crimean land, where the Russians were fighting the Brits and French, right? And Crimea has been a battleground for generations. Even today, I think the latest news we hear is there's going to be a war over Ukraine, right? So that is Crimea, I think. So when she went there, she observed interesting things. She made a chart of why people are dying, right? And she found that a startling fact. If you look at this visualization, this blue shows how many people died in a given month. And this pink here shows how many people died from an actual battle wound, like a bullet or a knife, a bayonet or something like that. When you look at this thing, like let's look at any one of these plots, you would agree that it's rather startling. Soldiers tend not to die, or people tend not to die from battle wounds in a battle. They tend to die from all sorts of other reasons. Isn't that remarkable? So she brought about the startling fact that the least likely cause of death in a battlefield is an actual battle wound. There are far more serious causes, and those causes were hygiene, because if you fell sick, you would be put into hospitals in which the sanitary conditions were absolutely terrible, right? And so she said that the right way to save people is to create clean hospitals in which patients are cared for. She was a lady of great compassion. Literally, she was called the lady of the night because she would go late at night when everybody is asleep. She would go from bed to bed with a lamp and attend to every single person who was sick and was mourning in pain. Right? So a person of great compassion. But this person of great compassion ended up founding two entire fields, at least, of knowledge. One is nursing. The field of nursing started quite literally with this visualization because she took this visualization, presented it to the emperor, to the empress, I believe, Queen Victoria at the time, or Queen Elizabeth, I believe. I may be wrong. I mean, I'm getting the Queens of England wrong at this moment, but either Elizabeth or Victoria. So Anne convinced her about it. She was very impressed and gave funding to create what is today, what would be called today, the first modern hospital where nursing is at the center of care. Clean, hygienic environment, sterile environment, and nursing is at the center of it. She's also the founder of data visualization. There is a magazine. If you go to medium.com, most of you have read articles on medium.com. Medium actually maintains an entire section, a magazine on its website that is called Nightingale. And as you get into visualization and get interested in visualization, I invite you to become regular visitors or regular readers of the Nightingale magazine, online magazine on Medium. And there are many magazines and things dedicated to it. Obviously, Nightingale is such a great personality, is larger than life figure from what we know. And remarkably, both driven by compassion as well as a keen intellect. So what we will do as a goal for today, I will show you how. Now, sorry, where did I suddenly go? What happened? Visualization. I did something silly. Where am I? The course portal disappeared. So give me a moment, guys. So today what we will do, I talked about the grammar of graphics. I talked about the fact that you could actually build visualizations up systematically. When you look at this visualization, and most of you have done some little plotting in Excel or Python and so forth, it may look very, very hard to be able to do this visualization, isn't it? Would you agree? Anybody feels it's very easy?
No. Many steps.
Yeah, it is very hard. It's a complex thing. And I have taken this as your first morning's goal. Today itself, you will learn systematically how to do visualization, basics. We'll start with a bar chart, right? And from there, we will end with this. This is actually a bar chart, but it doesn't look like that. And we will do that. So our thing is, when data scientists go to the bar, let's go to the bar. But before we go to the bar, let's start with a few basics. All right, so we are here. I will start with one visualization just to convince you that visualization matters. So there was a great statistician, today we'll call data scientist, who was completely annoyed that people underestimated visualization and considered it eye candy. Right? Visualization is an afterthought, and math is more, statistical descriptions are more the thing, and they're sufficient. People often talk about the sufficiency of statistical descriptions, and he wanted to illustrate the point that that is not true. Right? So what he did is he hand created a data, and the data is simple enough. So I didn't put it in a file. I represented it. So this is the x-axis, and we will have 4 data. Let me increase the font so you can all see the data. We have this data. Now this notebook I'll just upload. You don't have to do it. The y. For one data set, y1 is the y-axis, y2, y3, y4. And in last one, even the x-axis has been changed. So there are basically 4 data frames, right? So 4 data sets. look at the statistical description of the data. We are going to, and this is a little bit of a Python code, and you can see that summary, you take the data frame and you generate some statistical summary. You even stick in a linear regression model. I will illustrate that, and let me do that. Look at these data sets, guys. These are the four, 1, 2, 3, 4 rows of the data. I've marked them in Roman numerals. In Roman numerals 1, 2, 3. They all contain exactly 11 data points. The mean of each of the data set is 9. Mean of X, mean of Y is 7.5. Standard deviation is this along X and Y, correlations. When you look at this, and if you try to do a linear regression fit, they will all fit this thing, right? Because this is the slope, 0.5, intercept is 3. What do you infer about this data? Would you say that looking at the statistical description, they're probably very similar data sets? Would you agree? Would you come to the conclusion, or would you infer that they're plausibly very, very similar data sets, or essentially the same data set? Maybe they are different data sets drawn from the same sample, the same population. They're samples from the same population, isn't it? You would say
yes,
so.
Yeah.
Say so. Now, but then, and here is the thing, that the point you wanted to. So let's visualize the data. Statistical descriptions lead us to infer that they are probably samples from the same population, are very similar. Let's visualize it. When we visualize this data, and at this moment, we will learn how to do this visualizations, but I want to show you the result. And now, look at the 4 data sets. Do you see how completely different they are?
Yes.
Right. And despite the statistical similarities in so many statistical measures all agree with each other, nonetheless, these are entirely different data sets. Not only that, if you look at the last data set, you see something quite interesting. Y actually has no relationship to X. X is fixed, X is 8 all over. Except because you have this outlier point, it has skewed the linear regression line and make it look like the others. It is the influence of the outliers, how strongly outliers influence you. So what happens is when you make inferential models, when you do things, you do not know whether you are being misled or hijacked by some outliers or points of high leverage and things like that, especially with linear models, right? When you do linear regression models. It is therefore essential to visualize. Right? So visualization is a necessary thing. It's not an afterthought. It is not eye candy. And the point that he made. There is another lovely data set. So really, when we visualize, what would visualizations have said? If we make a histogram, do you notice that all the histograms, X, Y, the first column, left column is all the X's, and the Y column are all the Y's. If you just look, I will just decrease the font a little bit so we can present all of them in some. Do you realize if you look at the left column, that and Y column, just looking, I mean, each row, if you look at it, you would agree that the data sets look different, isn't it? Each row is one data set, and the data sets do look different in the histogram, right? So this illustrates how a simple visualization can disillusion you from false beliefs. There is another lovely example, which is which I like, which is more recent. We'll take this example of 13 data sets. This data set is and by the way, you guys will of course get this notebook so you can play with it. Of the 13 data set, they have been given some names, but ignore the names. I will now increase the font again. We will just visualize the first data set. So when you look at this data sets, once again, I will let you absorb the statistical qualities or the statistical descriptions of the data or measures. Would you agree that all of them look more or less the same? This would again lead you to believe that these are samples drawn from the same population, quite likely. Would you agree, guys? right? So obviously by now you're primed to the thought that this looks fishy, you shouldn't trust it. And let's see what happens. I've visualized here the very first data set. What does it look like it? The first data set looks like a dino, right? Your little T-Rex with small hands. However, when you move forward and you visualize the rest of the data set, do you notice that they don't look like the dino at all? They look entirely different, right? I hope we have made a strong case, and we can rest our case now, that data visualization matters. It's important. It is not an afterthought, right, in understanding data. So there are a few references, and this notebook will be online in a moment. So with that thing, any questions, guys, before we move forward? Now comes the do part. We will all do things together. I would assume the silence means no thoughts. So now, guys, get ready, get your Jupyter notebooks up. We are going to start. We are data scientists who will go to the bar, and let's see what happens. We will start with the first Jupyter notebook, and I want you to repeat after me. Right? Create a notebook in which you put these lines. Create two cells, and in those two cells, the first is make sure that you put this there. I hope you have run the visualization install. That's important. If you haven't, you must do that. Otherwise, none of it will work. Let's start by typing this much in. This is essentially the no-brainer. In the world of visualization, this will become a ritual. You'll always be doing this. Now, this is my stuff, right? It will just prettify or not uglify your Jupyter notebook based on your opinion. I'm not a great CSS artist, but what it will do is it will make your page look like this, the first one. But the second one is important. Please do this. I will give you guys 10 seconds more for this. In the meanwhile, I'll keep explaining. See, Matplotlib is the main library. If you want to import it, you say MPL. Now, what happens is Matplotlib is a low-level library, and it has all the geometric primitives, right? Plotting primitives. Usually, though, what happens is you don't need to use MPL. You need to, people have created a scripting layer on top. The scripting layer on top is the pyplot. And the pyplot gives you a lot of convenience functions and primitives or things to manipulate or create your graph. And so in this workshop, the only reason I mentioned this first line, which you'll sparingly use, is that there is a lot of power in Matplotlib that you can access by going to the underlying MPL, Matplotlib itself, rather than staying at the scripting layer. Now, the architecture of Matplotlib is, it thinks of everything as an artist, right? At the Matplotlib layer and the primitive layer, they are artists. There is a bar. If you want to make a bar plot, each bar, it's an artist element. It has to be created or painted by that, right? So there is a thinking in terms of artists and components at that layer. At the level of pyplots, we will think a little bit at a slightly higher level of abstraction and move forward. NumPy, as I said, it's based on NumPy. It's a good idea to include it. Pandas, we talked about it. Now we will add this line inline. Matplotlib inline. This is, of course, a magic command. When you do inline, means you don't have to keep saying plot.show, right? The plots will show here, not in a separate window. The other possibilities are we could do Matplotlib notebook, in which case the node, as you type the code, each cell at a time, the same visualization will keep changing, right? I encourage you to try the notebook option, because you write code and it changes. You write some more code and the same visualization changes. Interactively, you can build it. Or you could just say interactive on any plot, and you can get into that mode. So we will look at data. We need some simple data to work with. So I have created this data simplified data, which I will show in a moment. So guys, are we done with this? Can I move forward? If anybody wants to wait, let me know. We'll move forward with this. Now I want you to go load this data. This one will take a little bit of a making sure you don't have typos. So I'll increase the font size. Yes, I'm going to paste this part into the Zoom chat. Very good suggestion. Where is my Zoom chat? Here it is. Okay, data visualization with Python. I'm pasting this. Please copy it into a cell and run it. When you run it, and here, most of you know, is there anyone who has not worked with pandas at all? Please speak up. All of you have worked, which is amazing. So we can move fast. So this is a pandas data frame. We are just looking at the data. This data has only 6 rows, which are the 6 United Nations regions of the world: Africa, Americas, Mediterranean, Europe, Southeast Asia.
Asif, I think that in chat, I didn't get the URL, whatever you pasted.
Look into the data visualization with Python channel.
I think it was posted in Slack and not on Zoom.
Oh my goodness, did I post it in the wrong channel? Maybe, sorry. I apologize. We ended up creating, I created a channel and Kyle created a channel. So now there are 2 channels. Let me get rid of the channel that I created. I apologize. Leave. Is there a way to delete it? No. Okay. Did you guys get that now?
Not yet.
Yeah. Go to VZ-100 data visualization.
So are you putting on Skype chat or in some other channel?
Skype? No, there is no Skype. There's Slack.
Okay. Oh, Slack. Okay.
Please visit the Slack channel. Did you read the email we sent yesterday about?
Yeah, when we click on the Slack channel link, it is giving a 404 error.
Is because you haven't accepted the invite, perhaps. Oh.
I'm on the Slack channel.
So join the channel called VZ-100 Data Visualization. Okay, guys, let me show it to you. Huh? Here
it says not found error.
Okay, guys, so in that case, I will ask, let's take a 5-minute break. Bio break is called for anyway. We are at the end of the hour. Kyle, could you please help everyone here to get onto the channel?
Yes.
Yes, sure. And let's pause the recording. Oh. In the morning, we saw that we could take a very simple concept like a bar chart, and we went through a systematic journey of excuse me, of improving that bar chart, and finally we ended up with a fairly complex visualization, the landmark visualization of Florence Nightingale, the 2 roses visualization. Now we are going to do the same thing today afternoon using different libraries. We'll use Plotly, we'll use Altair, we'll use Seaborn. These are worth seeing how we can do the same thing in different libraries. We can move faster, perhaps, because today afternoon we want to do a bar chart and line chart, pretty much all 1-dimensional or 2-dimensional data, the basics we want to finish off today. So in order to do that, we'll have to move a little bit faster in the afternoon. I'm going to show you the same thing using Plotly. Plotly, as I mentioned, is a library based on, are you guys seeing my screen?
Yes. Yeah. The font is between.
No.
Are you able to see the code?
Yes.
Yes. So Plotly is based on D3. What it means is it will be interactive from the ground up. So the same code, the only extra thing we added is Plotly Express. Do you notice that we have one more import here of the Plotly library? So Plotly has two layers. One is the Express layer, which makes things convenient. And then there is the main Plotly, which has a lot more functionality. Very much like Matplotlib. There is PyPlot, a scripting layer, and then there's Matplotlib. So the same thing, we will go through, we will load the data, and we will do this px.bar. Do you notice that off the bat, I mean, just out of the gate, the plot looks better than what we had in Matplotlib raw. Guys, I'm getting echoes, so if you could please mute yourself, unless you are speaking. So one of the first things you notice is that it has automatically put the axis at an angle, or sorry, x-ticks at an angle, so that it doesn't occupy too much space. It's interactive. You can see tooltips. You can zoom in, right? You can pan, you could do things like, for example, you could move it around and so on and so forth. You could then reset it. So I'll leave it out to you to play with this. But I want you guys to at least get started. So could you please do this part? Import Plotly Express the way it is given here. And from here onwards, do this part, px.bar. Now, you notice that this code is no different, except that you have given the data as an argument.
Could you show all the way up the very first export Plotly Express as px?
Say that again.
It's the same data. The same data set.
Oh yes, exactly the same data set. Exactly the same data set, guys. So just copy over that notebook into a new copy. And we are going to redo the same thing, exactly the same thing using Plotly. Abhishek, this is the only new line here, right? This line, Plotly Express. Are we all there together, guys? Then one easy way is to copy the previous notebook, or and we have then when you do this bar, you get a bar chart, which, as I said, is a little bit better out of the box. So guys, if you want to be like, if you don't have the time to build up a complex visualization, it might be worth it to start with things that are D3 based, because you get to results sooner. Can I move forward, guys? Do I need to wait for somebody?
Yeah, just a
Go back again, huh? Okay, here we go.
Okay. Same as the one before.
Exactly the same. There's only one new line, this line. Import plotly.express as px. Right. And then px.bar. Albert, are you there? Let me know when you're done. Everybody online, are you guys done? Anybody, am I waiting mode?
no. Okay.
Okay, so I'll move that. So first thing you notice is straightforward code is just a little neater than Matplotlib by default. You can add a dash of color. So suppose you want to color by confirmed, right? How many cases confirmed are there? Let's do that. Suppose I do this and you'll see. Oh, region and color confirmed. So it basically color codes by how bad it is, right? Color by actual value. Right? Blue is low, yellow is bad. It's another way to send a signal. Now, suppose you want to rotate by the way, can you guess what would happen if I change this color to region? So suppose I say region. Can you guess what would happen? See, now the color is based on region. See, each of the bars has a different color. right? Maybe I should just copy this. Let me do this and keep. And this is by confirm. So it shows you how to do it with categorical features versus how to do it with numerical features, like this value. Confirmed is a number, whereas region is a set of values, regions of the world. So this is it. It's as simple as that. Now let's rotate the X tick axis a little bit. Suppose you don't like it that it is in this direction, you want to turn it the other way around. Now it is the other way around. So this is how you rotate the and this is the thing. The syntax of Plotly uses update x-axis. Right. Have we all reached this level, guys? Okay, I'll move forward. If you haven't, then stop. So let's try out the horizontal format. How do I make it horizontal? I just change the X and Y. The only change is, do you see? Orientation, horizontal. If you say orientation, horizontal. And you change the X and Y. I'll pause here. I'm moving forward. If anybody wants me to wait, let me know. Now, the next thing we want to do is sort by size, right? Remember, so once again, I would suggest that take the data and sort it in the data frame itself. Don't make the Plotly do it. And so no change, the same code, except that you have pre-sorted it. Exactly the way we did it in Matplotlib. When you do it, you get a plot that looks like this. So far, so good, guys? It's like,
Can you wait here? We just need to type the data.sort value.
sure.
The code, I'm posting it in Slack. If you guys
Oh,
want
thank you. Yeah, good. Thank you.
And now suppose you feel like resizing the graph, the same thing as we did in Matplotlib. Here, you can give the differences. You can give the height and width as arguments to the bar function itself. So when I do that, it becomes, notice the highlighting that I have given here, width and height. And I could do a bit more. For example, I could say 1,000. Now it looks like this. Closer to the golden ratio, I suppose.
Actually, if I joined like 5 minutes late, I missed the first assignment for what the PX is.
Okay, you joined late. 1 second. Let me pause here, guys, and review from the top.
Sorry about that.
Yeah, no problem. See, we have imported. So just like the previous notebook, make a copy of the previous notebook. And then in the imports, you add one sentence, this one.
Okay, Plotly Express as PX. Okay.
Right. And then what you do is the rest of the thing remains the same. Here, px.bar. Right? Instead of data.plot.bar, you do px.bar.
Okay.
Right? When you do that, you get the graph, which is highly interactive. You see tooltips, you can zoom in, you can move around, you can play with it, right? You get all these controls to zoom, right? You can pick regions and zoom into it. So in other words, you get a lot more for the same line of code. You notice that the axes are already bent. I mean, the tick marks are already at an angle, so to not waste space. So Plotly actually does a lot of this for you automatically. If you want to add a dash of color, you can color these bars by region. You just add color by region to that line of code. It becomes colored. If you want to color it by how intense, how many cases there are, you say color is equal to confirmed, then it becomes yellow if there are lots of cases there, like America's looks pretty bad here.
Got it. Thank you, Asif.
Yeah, sure. So Gopal, let me know when you have caught up. Huh?
Yeah, okay. Go ahead. I think I'll catch up as you go.
Yeah. Now, suppose you want to rotate the axis, you do the update x-axis. So this is the way. Now, what about the horizontal format? All you have to do is interchange the XY and let it know that you are trying the horizontal format. It will remember it. It will know that you're trying to do that. So you get this graph. Guys, are we all here? Can I move forward from here?
Yes.
Yeah, the next thing was we sorted it. How do we sort? No different from a Matplotlib. You sort it before you give it to the plotting library. It is always easier to sort in pandas than to do it here. So we give this, and the same thing, all we have done is passed it sorted data. So it looks like this. If you want to resize the graph, it's a little easier. The PX bar, what you do is you give the height and width right here. You notice and height, right? Everything else remains the same. Now the graph looks a little bigger. So far, so good, guys?
Yeah.
Gopal, have you caught up? Just do the recent ones, ignore the previous ones. Would you like me to wait till you type this in? Okay, take your time.
Yeah, I need to import all that stuff. Like a few more lines to type in.
Oh, Harini, you can give her the import. Give him the import. Sorry. Okay, then this is missing a title here. So we'll add the title also. Again, not very difficult. The same line of code, one extra argument. Do you notice that only one little thing has been added? Title. And it produces a graph now with title. Where's the title? Right up at the top. So I'll pause here for those of you who have to catch up. Gopal, let me know when you have caught up. Huh? Anybody else who is a little bit behind?
So this whole thing needs to be PX bar.
Right. And Harini has posted the code. If you are behind, then you should paste it, copy paste it. Otherwise, type it in because you'll develop muscle memory if you type it in. So it does look prettier, isn't it, guys? just out of the box, it looks prettier. Now, this title, it is left aligned. We can play around with the position of the title. We can say, for example, the same title, and this is something, now you begin to see the D3 underpinnings. D3, everything is JSON based. So, and those of you who are familiar with JSON would realize that this from here to here is a JSON syntax. Do you see that, guys?
Yes.
What I'm highlighting is JSON syntax, key value with a colon, right? So what we are saying is, let's look at this title here. We are not happy with the default location and so on and so forth. So we want to play around with it. So what you can do is you can create a title JSON object where you give the text X anchor, you say center, Y anchor, you say bottom, means bring it here, right? Then a little bit of a orientation and padding. And then everything remains the same as your previous code, but notice this last line of code. What are we doing? We are updating the layout. We are saying, change the title to this title JSON object. So something very interesting, you could have given the title as just a string, or you give it as a JSON object, very much like D3 lineage, right? D3 visualization library. When you become familiar, say, well, we are not going to cover that here, but if you were, this is how it is. Everything, JavaScript world is all JSON.
What were you saying that again? Sorry, lost you there.
I'm saying that if you look at title, it is a JSON object. It's like,
And how did you position it in the center that X?
yeah. So you just say X anchor, center, Y anchor. Y means where should I place it? X anchor, Y anchor, right? And so when I run it, do you notice what happened? Let me decrease the font size. Yeah. Do you notice that the title has moved to the bottom? Why did it move to the bottom? Because the Y anchor says bottom. X anchor says center, means X position is the center of the plot.
And the 0.5 means what?
Just a little bit extra to the, moving it a little bit around.
From the left.
Yes, things like
And the
that.
Y is 0. Okay.
0, yeah. So this is it. And so what you do is to make this thing apply, and you can do it to any element, very much like the D3 language.
So Asif, how the range of X and Y, how can we know that the visit is in a small decimal or?
Oh, no, it is not the range. It is not the data coordinates. It is the paper or the screen coordinates, just shifting it a little bit.
Just the title.
Okay, I'll just show you what happens. Let's see. Suppose I make Y is equal to 2, right? Let's see what happens. Oh, actually, it has to go from 0 to 1. So suppose I make it Y is equal to 1, right? Oh, where is it? It is up here. You can't see it, but it is like hiding up here. Most of it has gotten truncated because 0 is the bottom, Y is the top. These two statements are now contradicting. Y anchor and so forth are contradicting. When I make it 0 again, it comes back to the bottom. X at the center is like this. Now, suppose I remove these two things. Let me just remove these two and then do this, right? Do you realize that what is happening to this?
It just starts from the left and just goes as long as it can.
Right. And do you notice that it is touching the very, very bottom? It's just not properly anchored, right? It should be anchored a little bit upright, properly anchored. And I don't know how to say it. Look at this thing, the title. Do you see the text is being truncated? G is missing. Look at the bottom of the G.
Yes.
Right. So that is where you need to anchor it properly. And when you anchor it properly, then, oh no, again it is doing that. Sorry, I need to fix this, guys. I'll fix it and I'll tell you what is wrong. X is Y is equal to 0.1, let's say. Well, it's too much. 0.02. That's a tiny amount. We put, okay, now it's better. All the G's are coming in place. right? So these are the things, guys, you have to play with it. When you plot aesthetics, no? You spend quite some time tweaking the little bits of aesthetics. Well, so far so good, but what about my LaTeX and production quality code? Well, we'll try that. So everything remains the same. The sorting, the remains the same. There's that. But what am I doing? Do you notice that I've started adding LaTeX syntax? By the way, if you don't know LaTeX, then don't worry. LaTeX is a language for writing research papers, especially in the mathematical, physical sciences and engineering. Right? What it says is this is make it bold. This thing should be bold. And there is a little bit of LaTeX. So this part, guys, I will just give it to you on the Slack because it will be, unless you're familiar with LaTeX, this will feel terrible to type in. It will look very strange. So I'm just pasting it here, the whole code. Okay. So pick up the code from there. Most of the code is the same. Text BF means make it bold. Small means use small fonts and so forth. Let's run it. So what do you notice? I asked the x-axis label, y-axis label, and the title to be in the LaTeX font, and they are in LaTeX font. Do you see this, guys? Right. They are in LaTeX font, and adding the, like, once again, adding the values to the bar. Let's go and remember that on the bar, we wanted to put values. So what do we do to put values on the bar? It turns out that to put values on the bar, it's a lot easier. Here, you can say text position outside. This one line will do the job, and you can expand because remember this 1.1 factor to increase the x-axis. We did before also. We did that. But the only crucial line that we add is this line, guys, and this line. Update traces. So Harini, could you please paste that line? Or you know what, because Plotly we need to move a little faster. I'll paste the whole code, try to put it in a cell and run it. But understand that all I did was this one line, right? Update traces. Now, these things have showed up, these numbers have showed up. And of course, you could have formatted that numbers using the same locale and other things. Here, I forgot to do that.
So the numbers come from that outside?
Yes, do you see these numbers here?
Yes. So where do those numbers come from?
Those are the actual confirmed cases, no?
Oh.
Actual COVID cases. Trace, update trace. So this is, so the only change I made to the entire visualization was one line. Now, if you want to go minimalistic, just like we did in Matplotlib, what do? You keep the whole code the same, but you add this. What am I doing? The XY axis labels are fine. Plot background white, show legends false. And this part, this is the part that basically goes and disables lots of things. Tick marks, this, that, completely goes and disables them. And once again, guys, you won't remember all this. But the way to learn visualization when you encounter a new library like this is you understand while I'm explaining, make sure you understand, but you'll forget. But you keep this notebook with you and you try to alter it. You take this example and you play around with it and you adapt it to your data set. Gradually, you will begin to remember things. All these libraries have different syntax, different parameters, different this or that. So it takes a while. You can't memorize all this. You just have to look it up as needed. And it is useful to have good examples nearby, right? So keep these Jupyter notebooks with you because you'll actually use it in your workplace quite a lot. Right. So now what has happened? Do you notice that this is the minimalist version of it?
Yeah.
So far, so good, guys?
Yeah.
Right. So I'll give you the extra bit of code that I added is here. Now, at the very bottom, you are going to add this extra bit of code that basically goes and disables all sorts of things.
So I've already given.
I'm sorry, please say that again. Harini, say that again.
It was already given.
Oh, it was already given. Okay, wonderful. So then how do you do multi-bars? Very simple, very much like matplotlib. You just change it into an array, and then it will become multi-bar, just like that. No changes needed, right? And stack bar, how do I stack it? Bar mode is equal to stack, this one line. Let me just show that. Bar mode is equal to stack will cause it to get stacked. All right, guys. And then how do you do proportional bar chart? Once again, you have to create your proportional data. There's no shortcut to it. That's the best way to do it. And once you have created the proportional data, now comes how would you add it? So sorting, etc. You say bar mode stack. You remember that proportional is nothing but stacked bar adding up to 1, right? So you do that. Again, no surprises at this moment, right? We are not doing the magic was not, oh, sorry. The magic was not in this code. It was in creating this proportional data. And then it begins to look like this. But the advantage is that you see that these are highly interactive plots. You can zoom in, you can pan, you can do that. So one of the questions that you may ponder is, why don't we use it all the time? Right? By default, these are new libraries. People don't often mention it. I would strongly suggest use what is powerful, right? For each case. And matplotlib is very good if you can build it up layer by layer to the top. But if you want to quickly get some common cases done, then Plotly and all these libraries are very good. Well, how do we make the polar chart? Remember at the end of it, we wanted to make the polar chart. There, the code remains almost identical to matplotlib, except for this part, the main polar part. They actually have something called bar polar. Right? The rest of it is exactly from matplotlib, the same code I've copied here. One difference, while matplotlib looked at angle in radians, 0 to 2 pi, Plotly looks at angles in 0 to 360. So what we have to do is we have to convert radians to degrees. Right? That is one big change you have to do. Other than that, this part is new. Go figure. So Go is the underlying library of Plotly. Then you are making a bar polar chart. You have to give the radius, you have to give the theta, if you think about it, for each sector. You have to specify what is the width of all of them. This part I found repetitive, that you had to do it like this. Width, right? Then you give a color scheme. I just took a color scheme from non-color scheme. Mark line width to opacity. The rest of it is standard. Then a tick marks. This is Plotly's. I won't spend more time because it can take us a lot of time. But just to give you a sense that it's a bar plot is quite different from matplotlib, though they take the same arguments, theta, radius, etc., etc. The API is slightly distinct. It uses radius. So this, and you have to become familiar. You have to look at the documentation and make yourself familiar with it. But once you do that, let's run this. You will get a plot that looks like that. Frankly, I was not so happy with it. I preferred matplotlib because I had far more control and we could make a prettier plot. And this is the trade-off, guys. When you want to do simple things quickly, all of these other libraries, they get you there faster. But the moment you want to do something very specific, very custom and complex, then you have to get down to the basic, and the effort needed by each of the libraries, whether you're using Matplotlib or Plotly or something else, the effort becomes almost the same, right? You don't get that much difference in using one or the other. So this is another library, another thing. I'll post it to the website, the whole notebook. Play with this notebook. How many of you have managed to, not forget the polar, how many of you have managed to come this far?
I am done with that thing. Sir.
You did it, huh? Nice. Very good. And this one, I hope all of you reached the stack chart, or at least the basic one, multi-bar and minimal. Is there anyone who has not reached this far? We have all reached this. Huh? Okay. So this is it, guys. Plotly. So what's the lesson to learn? For creating simple visualizations, Plotly gives you more. With fewer lines of code, you get out of the box prettier plots. When it gets complex, well, then all bets are off. Right? Then you have to work hard. There is no free lunch. Likewise, there is another library, and I'll move faster now, Seaborn. Seaborn is based on Matplotlib, so not interactive. So what you do with Seaborn is, and I'll just do it again here. What is the import you have to add? This is the import that you will have to add. Import Seaborn. That's it. And now let's do that. How would you make a bar chart? The same code. Bar is this line of code. Let me keep running it from the beginning. When you look at this, what's wrong with this plot? Can somebody tell me? Anybody feels it looks ugly?
Yeah.
So Seaborn's whole premise was that it gives you prettier or much more professional plots out of the box. But in this case, it doesn't seem to be doing that job very well. Also, there is clutter that comes out here at the top. So we will now systematically improve it. What if you do tight layout? Not much. Y-axis is still terrible. It is in scientific notation. Let's first fix this clutter at the bottom, the X-ticks. How do we do the X-ticks? Once again, the rotation. All you have to do is rotate it. So this is one line of code you need to rotate it. Plot X-ticks. So this is, you realize that this is standard Matplotlib syntax. So to the extent that Seaborn is built on Matplotlib, you can any moment revert to Matplotlib under the cover. How would you format the y-axis? You know, this numbers, same thing. So other than this line, you're using everything else from Matplotlib. The same code from Matplotlib continues. This is the thing. Horizontal format, once again, all you do is rotate the axis. X and Y, if you interchange, it will go into the horizontal format. Right? There you go. And then sorting, once again, you have to sort the data on your own and then do this. How would you change the size? Nothing to do with Seaborn. The same Matplotlib code is the way to change the size. Adding the labels. Once again, when you add the labels, you're not doing anything. So the only Seaborn line of code is this, sns.barplot. Everything else is the standard Matplotlib. And setting the title is also the same, nothing new, right? Now, when we style the figure, once again, except for the bar plot, everything else remains the same as Matplotlib. So I will go a little bit faster on this. This, right? It goes like that. Later quality, you want to make it later quality. Once again, very straightforward. It will come through in a little bit. Yeah, there it is. Now, remember the DPI I've set to 72. What would happen if I set the DPI to 144? High resolution. See, the picture that you notice that the fonts get a little bit crisper. You can see it if you open the image in a new tab. Where is it gone? Here. Right. Because now you can render it to a slightly, it is taking a little more pains to fill it in. So those are minor tricks you'll learn when you're trying to create production quality code. Adding the values to the bar, that part is interesting. For that part, nothing changes. It remains the same. Right.
So I can ask you,
Mm-hmm.
so this X fix rotation is equal to 30 makes it that horizontal
Angle, at an angle.
Okay.
That's all. That's all. So now compare this plot to the original plot, guys. I hope you'll agree that even in Matplotlib, in Seaborn, following a systematic process leads to a much better plot. Right? And Seaborn ultimately didn't give you too much value because most of the code was from Matplotlib, except for that, it started out better. It just started out more colorful and better in the beginning. Right? So that is Seaborn. And then, of course, to do the minimal approach, once again, it is all the same Matplotlib code, nothing new. Yeah, this is it. It turns out that when you want to do multi-bar, it gets more complicated. Unless you know pandas, I won't explain this to you. Suffices to say that you need to represent data in this strange format in which there's a region confirmed. It is called melting of data, changing from wide to narrow format. I won't explain that unless you're very familiar with data transformations. But that's where the limitations begin to show up. This is where instead of being easier than Matplotlib, it actually became harder than Matplotlib. Right. And when you do that, you will get a visualization in a little bit. Where is it? Multi-bar. We are waiting for the multi-bar to show up. Okay, yeah, there it is the multi-bar. Now it gets, so this is the trade-off, guys. Something starts out, it is supposed to be making it easier than Matplotlib, but not always. You have to play with it. You have to play with this library all over again and make things work. Right? So I won't go more into it. Suffices to say that this can do that. The code for proportional bar remains exactly the same, just as you had to do it outside in the data frame level itself. Same thing you have to do here also. And you will get a proportional chart. A polar chart, by the time you reach polar chart, you realize it's very specialized. And in Seaborn, you begin to get stuck. It's very hard. Actually, I gave up after some time. Right? Obviously, I'm not an expert of Seaborn. And see, the premise of Seaborn was that most data scientists work with pandas. Seaborn works closely with pandas. The part that is true is yes, it does. It is true that for simple visualizations, Seaborn is faster, quicker. But the downside is that it is not an extensive library like Matplotlib. After a little while, you can see it has run out of steam. Right? Or that maybe that's my opinion because I don't understand Seaborn all that well, but that is where I would leave it. Now, so all of these libraries, of course, I'll immediately give it to you. Let's see it in the last library, Altair. Altair is a library that also is based upon D3 visualizations. So what is the extra import here? Altair. Import Altair as alt. Once you do that, then here's the bar chart. You notice that this comes out like this. Now, in this Altair, the syntax is a little closer to something called Vega Lite. Vega Lite is a pure, well, it's a layer over D3 to make it easy. I strongly suggest you spend time picking up Plotly, Matplotlib, and Altair. Altair, for example, here, the way to understand syntax is it follows the grammar of graphics very strictly. It says, see, you're creating a chart from this data, and your aesthetics, the representation will be bar chart, mark bar. Right? The way to understand this language is, okay, create a chart with this data of type bar, and then here's the encoding. You need to know in the bar chart what the X and Y axis are. So X is the region, or Y is confirmed, very much similar, except that what in the world is this colon N colon Q? N is for categorical variables. It's a nominal. They call it nominal. In our data science language, we'll call it categorical. In other words, something that is not of magnitude, something that is like cats, dogs, horses type. In this case, the region, is it Americas, is it Europe, and so forth. Q stands for quantitative, right? So that's what you have. Now you notice that to write this code, you had to write more code. You had to write a little more code, but then the simpler things takes a little more code, but actually the complex things become relatively straightforward. That's the point. So here the encoding is explained. What you need X, Y, you need to mark the color, sizes, rows, you need to give tooltips. And what are the data types you have? Q, O, N, T, G. The most common ones we use are Q, O, N. And for like in terms of categories, categorical, ordinal. Like for example, in the auto data set, you remember the horsepower, 2 horsepower, cylinders, 2 cylinder, 4 cylinder, 6 cylinder, 8 cylinder. Now, these are all different, in a way, it spans a region in between numerical and categorical, isn't it? Because you know that engines don't come with 3.5 cylinders. They only come like that, right? So it's ordinal. There is a discrete order there. So those are the 3 types that you have. Now let's look at the basic chart. Straightforward, but it took a little bit more effort to do it. But here is the part that begins to get beautiful after that. So to make it horizontal, you just interchange X and Y, right? You notice that the font size of confirm, the labels are already bold, and it looks pretty nice. Now let's go and prettify this, sort. Now remember that for Matplotlib, Plotly, Seaborn, you had to sort the data in the data frame itself and give it, right? But Altair gives it out of the box. All you have to say is, instead of saying X, you just say -X, sort by ascending or descending, right? Sort the Y values, the Y labels, by ascending or descending. That's all you do. And when you do so, guys, this one, yeah, you can, obviously, I don't expect you to keep up with it at this fast pace. I just want to show this to you because we are a little bit running low on time. But all of these notebooks, guys, please do study it carefully through the week. And one more thing, remember, every single day, we are giving help hours in the evening. Come to the help hours. Any bit of code is not clear in the notebooks, come to the help hours, we'll explain it to you. And all of these notebooks will be reviewed by our teaching faculty at a slightly slower pace for you. So if you miss something or are confused, please do come to our clinic hours throughout the week. Yes, go ahead.
So we use a tool called Datadog, and it looks like they probably use some data science to do some of their graphics. And
Almost all of them are
using
D3
all these
based.
libraries. They look, I mean, the more I look at this and that, they use all these libraries.
Yes, yes.
Okay.
So how do I, now that we have sorted it, how do I, the sorting is done, how do I resize the graph? What is the extra point I bring in? This one. Okay. Do you see that dot properties with actually 12,000 looks better. Let's try. Oh, 800, only 800. Oh boy, this doesn't look like the golden ratio. We may change it. Let's see. Oh no, it came out pretty good. Okay. So we resized. So size are properties of the aesthetic. So we said bar chart and code it with data like this, and these are the properties. And you can give lots and lots of properties, right? How do I set a title to this? Very simple. Title is another property of a graph. Right. And when you look at this, you begin to, like those of you who are familiar with Vega Lite, I don't assume many of you are, because it's a whole world of visualization out there in JavaScript. This is a syntax coming more or less from Vega, right? And D3. Now, how do you customize the X and Y axis? So you see these labels. Let's go customize the labels. How would I do that? So what happens is that you can actually change the labels. At this moment, what are the labels? It is just the name of the feature, isn't it? Confirmed and region in the data frame, but you can get that by using this syntax. No, not here. Customize the X label. Then you have to say X is not just equal to confirm colon Q, but you have to say axis. And this axis language comes or is inspired by Matplotlib's thinking of axis as any object that is there in the plot. Yeah. But I won't set it like that. It's a alt axis title is this. Yeah. This syntax, I'll let you absorb it for a moment. It's an odd way. It's not as intuitive as, let's say, Matplotlib was, where you just said plot.x label is, and you gave it a label. Yeah. It's a little more complicated here. So one has to get used to this idiosyncratic way of setting the x-axis title and the y-axis labels. Yeah, that was one part I felt was, in my opinion, was unnecessary. It could have been simpler, right? Isn't it? Everything else looks neat till you hit this peculiar bit, right? So what happens is that now alt is altair. X means it's a function that to which you can give specific properties, specific inputs. Likewise for Y. And so this is the part I felt perhaps could be simplified, but it is what it is in this library. The rest of it is straightforward. Properties is nice. It's giving you key value pairs. Now adding explicit value to the bar, remember you have to put values to the bar. Where is it? How do we put bar? You have to again create a text entity, just as we did for other libraries. But it's easier actually, because all you're saying is baseline, align left, this, that, weight, Salmon. And let's run it and see what it does. It turns out nothing got rendered. We created a bar chart, we created a text, but when you put the two together, nothing comes up. Why? Because Altair is willing to render only one plot. So you need to add these two up, right, to create a compound plot. And that is one missing. By the way, this is a very common mistake people make in Altair. They say, just now this was working, this part was working. And now suddenly when I put these two together, they are not working. The answer to that is you do these parts, two parts, but then you have to do this. You don't need to even give the properties, but it is a good idea to. You have to do bar plus text. You see that, right? You have to say that explicitly. Then when you do that, you'll get this, right? Do you see the numbers on them? Right. It will come. I'll let you improve this. For example, this scope for improvement, this x-axis should have gone far enough so that this number felt it was inside it. So you should increase the x limit. I'll leave that as an exercise for you. How do we do multi-bars in Altair? Well, you have to repeatedly create different bars, and at the end of it, add up the two. Again, create a compound chart. Yeah. Confirmed plus death is this. Let's try this. When you do that, oh, where am I? Yeah. So you get this compound graph like this. And
Could we get that in the text in the Slack test? The
all of it, you know, this is
cell?
my notebook. What
Okay.
I'm doing is I'm going to just give it as is. Actually, Harini, let's do one thing. Let's post the notebook for everyone to take in right away. The whole notebook. Maybe Harini has stepped out. Kate, could you please help me with that? Let's put the whole notebook on the Slack. This is the bar plot Altair. Anyway, so I'll put it in a moment. Let me just finish it. This one, I don't expect you to code as we go along because two reasons. The syntax is slightly different. It's very D3-like. It takes a little while to become familiar with it. But if you, see, one easy way of learning a library is to do something you have already done in a language that you're familiar with. You just became familiar with doing this in Matplotlib. And so we are repeating it in Altair. So all you're doing is you're seeing the code, how it does it for that, right? So to create a stack chart, the magic word you have to use is transform fold. You're folding on these things, right? So little gets more complex, and I won't explain these things too much. Suffice is to say that, see, these plots look pretty, right? They are certainly good-looking plots, and you see that right here. And the interesting thing with Altair is you want to go and see this Vega's source. Ultimately, Vega is nothing but a JSON file, the Vega code. Where am I? Why is it not magnifying? Okay, I wanted to increase the font size. It's not letting me do that. And you can open it up in Vega editor. Vega is a visualization framework. Okay, here we go, right? So in the world of visualization, D3 and Vega, etc., are very dominant. We don't, as data scientists, we feel differently because we want to stay close to the machine learning, which means Python. But if you put in a little bit of effort, you will become very familiar with the syntax of Vega. And if you look carefully, it is nothing but JSON, right? 6 regions. This is the data set. Does the data set make sense? Given region Africa, confirmed, death, recovered, active are these.
Yeah.
Then what is the actual UI code? If you look at your code, see the complicated code that we wrote here. Let's look at this. Properties is this. Let's try to match it in the Vega. Properties, color count, where is the, height. Do you see in the properties, you see height, width. Are you seeing it? And title. These were the 3 properties, guys. Right. Then we did transform fold. Here it is. Transform, and it has a fold as this. So all Altair is doing is it is giving you a Pythonic API over the Vega-like JSON data format, representation format, right? So, which is good because then you stay in the world of your Python, which most data scientists do, and they don't have to worry about, and you can just run it here. Let's say that you run it here, you see your visualization come. And sometimes what happens, right, it helps to just, if you become good with the Vega, you can go and edit it here, right? For example, I don't like the title case by, this is, suppose I change the word, right? And you run it. So then you see it happen, you see it change, very much like in the notebook. But if you get used to visualization, you might you might find it easier. And this thing gives you the data. It's pretty, these things are pretty powerful in the visualization world. It is good to become familiar with that also, right, as you do it.
So also there you showed the data is in JSON, correct?
Data is in JSON, yes.
And you can connect it and you can want. So this is very useful for data that you get.
Yeah. So let me give you an example. Suppose you write your pandas code. You generated this Vega Lite. Guess what you can do? You can put this thing into your web page. Isn't it?
Healthcare solution. So this would be awesome.
Absolutely.
Using size and dashboard and all this crazy stupid stuff. And
yes.
It's a mess.
It's a mess. After a little while, once you get used to all these libraries, you will find that those GUI tools that help you drag and drop and do things, they come in the way. They help you make the easy stuff, but after a little while, they really become annoying. Right? So visualization is best done in code. It's just like that, you know, people who are into art, they want to work with Photoshop and Illustrator. They don't want some website where you drag and drop and things happen to your photograph. Remember this quick things, click, 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 because the easy stuff is easier there, but you can't go beyond you get boxed in, right? So worth doing it in code properly. Right? So I won't get through more of that. How would you add tooltips? Same thing. Now you have added custom tooltips. Where is the tooltip part? Literally this, right? One liner will add tooltips to you. Then you can do grouped multi-chart, and we won't get, yeah. So one nice thing with Altair was, what I liked is, do you notice that when you do grouped, what is the extra thing we did here? Let's find out. What did we do extra? I'll remember where we did the change: mark, bar, encoding, title, as, color, tooltip, row. Yeah, this is it. You break just this one little line helps you generate. What it is saying is that divide the data into different rows, one row per region. Is it one row per region, guys? Here, look here.
Yeah.
Okay, one row per region, and it is divided up like that. And so you end up creating very powerful graphs with one-liners. Anyway, what I'm trying to illustrate is, guys, that stick to a language, to a grammar. If you think like that it's a constructive process, you can create very complex visualizations. And especially Matplotlib predates grammar of graphics, but you can take that approach to building the visualization the way we did. We reached a Florence Nightingale's 2 roses just by following the systematic process, right? But libraries like Altair and Plotly, which are based on D3, it is much easier to follow the grammar of graphics, because D3 is literally grammar of graphics writ large. So that's that. Proportional bar, no, there's nothing new here. You have to do it the hard way, the way we did it. You know, you have to create your pandas data frame in which you have those properties, and there is nothing new here. Absolutely nothing new. It's the same old code, because the work had to be done. What just happened? The work had to be done in pandas. So when you do it, you'll get this. I like the look of it, actually, Altair. I like the fonts are usually very clean. Do you notice that it has clean fonts and the ticks, X ticks are clean? Right? So that is that.
So say this proportional thing, you wanted to see the actual numbers.
Little. So at this moment, it is a tooltip, but if you want to add it, so here's the thing, guys. In each of these plots using other libraries, right, I've deliberately left things incomplete. Right. So you know that I showed you that you have a text element, right? Yeah, here. So where did we go? The text element is here. Look at this. So what do you need to do? You need to take this, copy paste it there, and adapt it. Isn't it? Right. So take that as a homework, like have fun with it. Use these visualizations as starting points to further build upon it and do your own stuff. Right. So that is that, proportional, and I won't go anyway. So guys, I will end the bar plot. It has taken us a lot of time.